All right, good afternoon, everyone, and thank you very much for joining us today for the Michigan Forest Biomaterials Institute webinar series to advance mass timber in Michigan. On behalf of MIFB, I am Julie Manley, the Vice Chair of the board, and we're just going to jump in as fast as possible because we've got a great agenda for you today. Next slide, please. So in terms of logistics, very simply, we are working off of Zoom meeting today, not the webinar form. So as a result, please mute all lines as best as possible. If you're not presenting, keep your webcams off. And then also submit questions in chat as much as you would like and as often as you would like. We will try to address them as many as possible at the end of Archie's presentation. And also, if there's any that we didn't get to, we will be able to send them to Archie, and he's agreed to address them. So feel free to hit him up with questions at any time. So with that, I will do the next slide is a brief introduction of the Michigan Forest Biomaterials Institute. Long name, we go by MIFB, and we are really a connector of industry, government, and academia to sustainably advance Michigan's economy through forest biomaterials. We foster sustainable forests, communities, and economies through innovative and responsible production, use, and recycling of forest biomaterials. We do a lot of convening, we're educators, we're independent and nonprofit, and we're also very much volunteer. So with that, I am actually going to, I think that's enough on MIFB. I want to get right into the heart of what we're discussing today. So with that, I'd like to, next slide, introduce Shannon Lott, the Deputy Director of the Michigan Department of Natural Resources, who's agreed to join us today as for the opening remarks. Shannon has a BS in Wildlife Biology from Grand Valley State University and an MS in Forestry from Michigan State University. She's worked for the Department of Natural Resources for over 23 years. 20 of which were in the Wildlife Division and a little under 2 years as the Forest Resources Division Assistant Chief. In the spring of 2019, she was then transitioned to the Executive Office as the Department of Natural Resources Deputy for the department. So with that, thank you. I'll turn it over to Shannon.
All right, thank you, Julie. Can you guys hear me with my headset? Hopefully. Yes, okay, good. I can hear you way better when I put this on, so I thought I better. So I'm really excited to be here because this is one of our biggest undertakings right now for a team that we have in Michigan that is promoting mass timber, and many of you were around when we did the summit last spring. And one of the things that came out of the summit was the need for understanding of the codes that are allowed or that are already under law in Michigan, but also the changes to codes that are needed here in order to really promote the use of mass timber like other states have already done. So we have a handful of states that I have talked with already about the way to go about this and to really open the code a little bit more for flexibility and more stories. Right now we can do 4 stories in Michigan in mass timber, but we want to be able to expand that. So what we're working on right now as far as codes in Michigan is working with our LARA, which is our sister agency, to talk about the next steps in changing the administrative codes and then also anything statutorily that may need to be changed. Other states have done this by incorporating the 2021 IBC by reference. Other states have added a chapter just on mass timber. Other states have opened the entire code and went through and made those changes. So there's different ways that we can go about this, but we're actively meeting with our folks at LARA to go through the next steps needed in order to get the 2021 IBC adopted. And right now they're working on getting the 2018 finished here in Michigan, but in cross-referencing those, some of our team members have cross-referenced the 2018 code with 2021 and where those changes would be needed. And we think that we can do these things in tandem. So we don't really need to wait until the 2018 code is completely done and adopted here, but we can start having those conversations about the 2021 code. So I just wanted to be on, and Julie asked me to be on here to kick this off with Archie's presentation, because that is all very good news. And we are, our team is still running strong, that we had put together to run the summit last year with all the continuing education and with MIFB's help on all of these continuing education webinars. That's really the only way we can do it right now. So, but it's been helpful, and I hope it's worked for all of you, because more people can join throughout the country and internationally as needed to help us move this conversation along. So that's where we're at with Michigan's codes and how we're trying to move forward. So I'm going to hand it over to Archie to show you what the possibilities are.
Well, thank you, Shannon. Really appreciate the great introduction. And we'll now you'll notice there's a little difference here between the photo and the live. I don't know what happened, but maybe we'll get back to that. We'll see. You know, these barbers, they just weren't working, and I just kind of gave up on them. So that being said, we want to talk about mass timber, but I'll do a brief introduction here. First of all, I always tell people I think it's vitally important that you know who is talking to you and why they're talking to you. So, you know, WoodWorks is a nonprofit organization. We're funded by the wood industry and USDA and FP Innovations up in Canada. And our job is really to assist in using structural wood products in commercial buildings, multifamily. We just don't do things in single family homes. So that's what we do. We don't sell products. We try to remain very objective and give designers, architects, engineers, contractors, specifiers, developers the best objective information we can, so they can make decisions they need to make, and then we can assist them along the way. Now, for the last few years, my territory has always included Michigan. Now this year we went through a little bit of a change because we have added more people in the last few years. We just added a couple more this year actually. So our geographic area has changed a little bit. So I'm going to introduce to you Anthony Harvey, who is, he's actually going, this year he'll be taking over for me in Michigan because he's in Kentucky. And the geography worked out really well. I really hate to give up Michigan. It's been enjoyable. It's been fun, and I'm sure I'm still going to talk to a lot of people. But Anthony is really, really good. Anthony's an engineer in Lexington, Kentucky. Been with us over a year now. Well versed. You're in good hands. Anthony, I'll let you, if you want to introduce yourself and say a couple of words.
Sure. Yeah. Good morning. Good afternoon, everyone. Happy to assist on any of your project assistance needs or any of your questions on mass timber or anything wood in general. And I'll throw my email address down here in the chat if you're ever to want to reach out. Be happy to talk to you.
Thank you. And again, feel free, reach out to Anthony or myself. However we can help, that's what we're here for. So that's not an imposition. Let me stop this video now. You don't need that for us to do the presentation. So we're going to talk about the new tall wood code provisions.
Excuse me, Archie?
Yeah.
As you get started here, we're having, I don't know if anybody else is experiencing this, but the audio is kind of cutting out a little bit. We hear you. It just gets fairly light at times. I don't know if there's any, I just wanted you to be aware of that in case there's anything on your end.
Okay. I don't know. I'm plugged into the internet. How does it sound right now?
It's been this is Brian. It's been okay where I am.
Okay, maybe it's my end. I'll chalk that up to my high schoolers using the internet today. Thanks.
And now that we pause this screen, I may, oh, there we go. It wasn't advancing for me. Sometimes it freezes up when it sits. So hopefully everybody can hear me okay. If not, just again, let us know and we'll try to do something about it. So Wood Products Council, this is the AIA slide that we provide. So WoodWorks is part of the Wood Products Council. I'll let you read through the course description. I won't read slides to you. You can read them far faster than I can read them to you, and to give you a sense of what we're going to be talking about today. I will say that I've had to pare this back a little bit for time constraint. And as I get towards the end, if I can't make it all the way till the end, some of the slides I've arranged it that shouldn't make a whole lot of difference. It'll get a little bit more technical at the end, and we can always cover that individually if we need to. So I'll be going through this somewhat quickly. Learning objectives. The description should have handled that. So this is really an AI requirement. So we don't need to dwell on that. So we're looking at the new construction types in 2021 IBC. So we've always had type 4 construction, which is heavy timber. We have added type 4A, 4B, and 4C, and you can see the differences, and that's what we're going to spend a great deal of time on. So here's a pictorial of the new building types, and I think in this case a picture is worth 1,000 words. Again, I won't go through every word on this slide. I'm going to let you take a look at the differences between these three buildings. You can see the building height, the allowable stories, the allowable building area, and the average area per story. And then what we'll do is we'll get a little bit more into the specifics of the differences of why these three buildings are different heights and different size buildings. Over on the right is our type 4 heavy timber, which has been in the code for a long, long time. That still remains as type 4 heavy timber, but you can see we're limited to 6 stories, 85 feet. So it's a little bit smaller than the code provisions for the new buildings. And you can take a quick look at this slide. We won't spend a great deal of time. Just know that this is in the code. These are all sprinklered values, but it'll give you a sense, for the height, for the number of stories, for the footage, and we really saw that in the previous slide. So you can always refer to these tables in the code to access this information. And then unsprinklered is substantially different, which makes perfect sense. So as it mentioned, in almost all cases, sprinklers will be required. So first of all, we're going to talk about type 4A, which is the tallest of the new buildings that we can do, up to 18 stories tall. And the building you see in the middle, this really was kind of a precursor or an example that was used to develop the code. So this is Brock Commons in British Columbia, Canada. And oh gosh, this was done about 3 years ago, I believe. I did get to see this building right at about the stage it was at right there when it was just about complete. So that is 17 stories of wood over 1 story of concrete. Now, again, we can see based on occupancies, some of the differences, especially areas that we're going to have. So that will be a big driver of, what we can do and how much area. Business, typically, we're always going to be able to get more square footage. So in order to achieve 18 stories, we need to protect the wood 100% with non-combustible protection, which is usually going to be drywall, which will probably be the most simple, direct way to do it. And that's how we're looking at this today. So as we look at the differences here between the primary frame and the exterior or interior bearing wall, the differences, you can see the hour differences. And they're represented over on the right-hand side pictorially, to give you a good example of what are the requirements for this building. So remember, this is being the tallest building, it's going to be, excuse me, the most restrictive. So here we're looking at how much non-combustible protection at a minimum do we need for these different hourly ratings. So 3 hours, we need 120 minutes or 80 minutes at the roof. And I'll let you read down the slide. So depending on where we're at in the building, the requirements will change. So you look at the bottom of the slide, and 1/2 inch type X, we're typically going to be using type X gypsum, gives us 25 minutes. 5/8, which is going to be the norm, most likely, is going to give us 40 minutes. So in the case of 120 minutes, we're going to need 3 layers of type X 5/8 gypsum. So again, this is a table that is going to, again, tell us definitely what we need to do here in the code. So we can refer to the code and we can easily see, you know, what's required here. And again, protection contribution in minutes, 25 and 40. So as we mentioned, different layers based on 5/8. So we're looking at passive fire protection. But mass timber also has its own fire resistance rating, like we've always used in type 4 heavy timber construction. So depending on the size of the members, we can use the char rating to obtain some time, I guess you would say, from the wood itself. And we delay additional combustion with the gypboard. So we can take the fire resistance of the unprotected element and add it to the non-combustible protection. So over on the left, you can see a wood member that was placed in a fire which charred. And charring is going to give us that protection. It's going to allow that wood to remain cool under the char for a longer period of time, and we can calculate that very, very exactly, so we know how long that wood can survive in a fire based on the size of the member. So in some cases, we can simply use the non-combustible material or maybe just mass timber, depending on the building type. Now, just like we've always had in type 4 heavy timber, we still need to meet minimum sizes based on where those wood elements are going, whether it be a column, a roof, or a floor. So this is what we're really familiar with in type 4 heavy timber construction. So when we look in the code, this will have a table similar to this, which is going to show us solid sawn, when we say timber, glulam. I think most people are familiar with glulam. SCL stands for structural composite lumber, or what we typically are using, LVL, LSL, and PSL would fall into that category. Likewise would OSL if it's available in these sizes, which I doubt that it will be. That's a little bit of an odd thing. So LVL, LSL, PSL. So you can see the different sizes because the engineered wood sizes are different than what an actual timber is. So we do have a nice referral here, so we know, for instance, if we say, well, I want to use glulam and not solid sawn, we know exactly what minimum size we need to use. So the floor panels or decking, so 4-inch thick CLT, and notice that is actual thickness. Most CLT panels would usually be 4 1/8, but the manufacturer, that can vary a little bit. 4-inch nail laminated timber, dowel laminated timber, or glue laminated timber. That's what the acronyms are for. So it's still the same, 4 inches, but that's nominal. So let's say nail laminated timber, 4 inches would mean a 2x4. Similar to DLT and GLT would be similar. So technically, you're looking at 3.5 inches there. Possibly in the glue laminated timber, you might be allowed to use a 3 1/8 because glue laminated beams come in 3 1/8 thickness. And then 3-inch thick nominal decking, and then we can cover it with 1 inch or 15-30 wood structural panel or 1/2-inch particle board. So there's a couple different ways of doing this. And then we have similar things that we can look at for the roof. We're not quite as thick. We can get by with 3-inch thick or 2-inch decking. A lot of this has been taken right from the heavy timber that we've been used to using. Exterior walls for type 4A, B, or C can be CLT or non-combustible. We cannot use fire retardant treated wood in the exterior of those walls of 4A, B, or C. In type 4 heavy timber, you'll notice CLT or fire retardant treated wood or non-combustible, because we've always been able to use fire retardant treated wood in that type 4 heavy timber. And remember, we can only get to 6 stories high with that. So it's not quite as tall of a building. So that's one of the subtle differences you'll see in the code. And then you can see the differences between 2018 and 2021 that we need either 6-inch or 4-inch, depending on which code you're looking at. So mass timber walls, laminated construction 4 inches thick, solid wood construction, minimum 2 layers of 1-inch match boards. I'll let you read through the other interior walls in the type 4, and you can see the differences here. Again, reading every slide to you really doesn't make a lot of sense when you're reading it faster than I am saying it to you. Primary structural frame. So here's some examples. So 3 hours required. So we need at least 120 minutes. So we could use 3 layers of 5/8 type X. If mass timber counts for an hour, we can get by with, we're getting by with 2 hours of protection, basically, is what it is. Floor panels, we need 2 hours. So we need at least 80 minutes. And again, I'll just let you read through the different ways of arriving at this. I guess the bottom line in most of these buildings is we're going to see a lot of type 5/8 type X gypsum for sure. We can see that if we use 3 layers, we can get to 120 minutes, and we don't need to count fire protection from the mass timber. Now, in the type 4A, we need floor surface, roof surface protection, exterior wall protection. So here we can see the floor minimum 1 inch thick. In this case, looks like a gypcrete type product. Minimum 2 layers 5/8 type X gyp on inside face. I'll let you again read down. It's really well laid out as to how we can arrive at these type of assemblies. I should mention, I could have mentioned it early on, this presentation is available on our website in its entirety in PDF format. So you can always refer back and find this information, which I think is nice because it's condensed a little bit and maybe easier than just perusing the code. So here's an example of a 2-hour floor. So we said, well, we can get 40 minutes from the mass timber. We use 2 layers of type X 5/8, or we simply use 3 layers of 5/8. And it also shows that minimum 1 inch non-combustible floor covering. So the primary frame, again, the glue lam beam, we can get 60 minutes of mass timber and 3 layers of 5/8 type X. So there's a couple ways of doing this calculations. can be used. We refer to IBC 722, which uses the NDS Chapter 16 for calculating fire resistance, or tested assemblies in accordance with ASTM E119. The one caveat is not everything is tested. So calculations are really, really critical for these types of buildings. It's great to have tested assemblies. It requires a lot of time and money. So we're not going to see every assembly undergo a test. But there are more and more that we're seeing. And on our website, we do have an inventory of most of the tested assemblies. So there's a few different ways of doing this and calculations like we mentioned before. So I think if we, for right now, the main point is to skip to the bottom right there, ASCE 29. And we're looking and saying we can do this in accordance with Chapter 16. So when you're dealing with a building official, we refer to that and say we're calculating our fire resistance per Chapter 16 of the NDS, which is allowed in the code. And there's a lot of information in there for different products. So this is where the architect is going to want to refer to this typically to the engineer for this type of information. The nominal char rate of 1.5 inches is recognized in the NDS, and then we can base that on calculations, and it's a very conservative calculation so that we have some leeway there. So basically what happens if our beam, we lost, let's say, 1 inch around the perimeter of the beam, but the beam were oversized by 1 inch for the design load, we're still capable of carrying the design load. If we add 3 inches to it, we can basically get 3 hours protection. 1.5 inches is going to give us 1 hour. So we can see the difference here with, the normal wood. We have a char layer, the base, the pyrolysis zone, and then a pyrolysis zone base. And then we get down to what we call the cold or the normal wood, which is still carrying full load. And we can see some of the adjustment factors here used for the fire design. Tested assemblies, different test reports by different agencies. Anyone who's accredited to do this. And of course, UL usually comes to mind because it's the most readily, I guess, but there's a lot of other ones and they're all equally capable. We have very good information on our website. This is one article that's on our website. Really tons of information there. So I would advise anyone, when you have time, go to our website, take a look. When you need something, but you may want to peruse it ahead of time and just get a sense for what's there. Contact Anthony or myself. Let us know if we can find something for you and help you. I mentioned this inventory of fire tested mass timber assemblies that is on our website, and this is going to be in constant flux because we're going to keep adding information to this as they're tested. So type 4 construction is shown right here in 602.4 of the code. So we're really describing this is what we can do with type 4 construction. And again, I'll let you read through that. And it's really, really straightforward. It really doesn't leave much room for interpretation. So type 4B, we covered A. Now we're 4B. So this building, we can't get quite as tall. We can get to 12 stories, 180 feet, less square footage. The building that was used as the example, I guess you would say, to set this one is Carbon 12 that was done several years ago in Portland, Oregon, which is the building in the middle, and that's an 8-story mass timber building. And I did have the opportunity to tour that. It's not a huge building, but it really kind of set the precedence for doing this. And I believe right now it's, as of this point, it's the tallest finished mass timber building still in the US. So again, we look at the occupancies and we can see, okay, what are the differences between what we can do here with different occupancies as far as, especially the area per story in the building area. So business, again, we're, office type buildings, business, we're going to get to rather large buildings. We need non-combustible protection on all surfaces of mass timber except limited exposed areas. It's kind of a compromise. Now we're limiting it to 12 stories instead of 18. So we're getting a little bit more leeway here to expose some wood is basically how we're looking at this. And this can vary a little. You can calculate this. We'll go through a couple examples. So 20% of the ceiling or 40% of the wall can be exposed, but that has to be calculated. There's some caveats to that. And again, now we can see we're not using any 3-hour type assemblies in this building like we did in type 4A. So everything here is 2-hour. And again, we can look at this table and say, how much non-combustible protection do I mean? So minimum non-combustible protection based on where we're at and what we're doing in the building. Type 4B still requires floor surface protection, similar to what we did in 4A. And again, we can look at the roof and we can look at the exterior wall protection. So it's just going to be a little bit more lenient, a little bit less than we had in 4A. So here, again, we can say, well, we can get 40 minutes fire resistant rating from the mass timber. We add 2 layers of 5/8 type gyp, or we simply use 3 layers of type 5/8 to achieve the 2-hour. And again, the same thing with the beam situation. We can say, okay, we can get 40 minutes of mass timber and 2 layers of 5/8 type gyp will work. So this one I think is a little bit simpler because everything is basically 2 hours. So limited exposed mass timber is allowed. So mass timber beams and columns, which are not an integral part of walls or ceilings. I'll let you read through the rest of this because, again, you're going to glance through that quicker than I can read it to you. And then just to make it a little trickier, we can do a combination of the ceilings, beams, walls, columns. We'll just take a look at how we could do that. So again, I'll let you read through this. Just know that this formula is here to use. So a design example. So we're looking at 800 square foot dwelling unit. So we can look at the numbers here and say, okay, if I want to, we could expose 160 feet or 320. We have these variables that we can look at. And a lot of this is going to depend on the aesthetics of what the architect is looking to do. And I think a lot of it's going to depend on the actual structure, let's say, of this unit. What makes sense. So we have some leeway here to take and I guess run with this in a way that we can really say what's going to be aesthetically the most pleasing and how do we structurally accommodate this to help with that. I think we need to look at both. So if we mix the mass timber walls and the ceilings, then we can come up with, 120 feet of walls and 100 feet of mass timber ceiling. Now, there are some requirements. Unprotected portions of mass timber walls and ceilings shall be not less than 15 feet from unprotected portions of other walls and ceilings, measured horizontally along the ceiling, and from other unprotected portions of walls measured horizontally along the floor. So we want to keep these elements separated. I think really for, this code, I think it's very, very practically done. There was a lot of logic used when they developed these codes. So now we're looking at 4C, and now we're looking at 9 stories. So here, we do have, I think, a little, kind of a tough deal in a way. We can get to 9 stories in business, but we can only get to 85 feet. So, that may be a little tricky. So we might say, well, maybe 8 stories makes more sense, but we are allowed 9, but we're still limited to 85 feet. Now, all mass timber surfaces may be exposed, with exceptions of shafts, concealed spaces, and the outside face of exterior walls. So again, this is more lenient than 4A and 4B because it's a smaller, less tall building. Again, we're looking at 2 hours for all of these elements. Now, we don't need floor surface protection or roof surface protection. The exterior wall, we still need protection. So this is different than 4A and 4B. So now we're not looking at any drywall, so we need to size the materials to achieve the 2 hours by having a large enough mass timber element, which is not really that difficult to do, but it's going to add some more wood. Same thing here, 2 hours of mass timber fire resistance. No non-combustible materials required. So here we get a little better sense of some of the differences between what we're doing here with the different buildings and the hourly ratings. I mean, this is just what we went through, and this just shows it to you in table format. So 4A and 4B, non-combustible protection required. In 4C and 4 heavy timber, we do not need non-combustible protection. And again, we can see the differences in the hourly ratings. Like I mentioned earlier, this information, you can get a PDF, and if I can always send a PDF out to MIFB if they want to distribute that. Now, we do have a couple differences here between IBC 2021 and IBC 2018 for heavy timber. And I mentioned look at the bottom row, we cannot use light frame fire retardant treated wood in A, B, and C. But we can do that in 2021 IBC. So previously in heavy timber buildings, just heavy timber, we were not allowed to have concealed spaces. But now in these newer buildings, we are allowed to do that. So here's things we couldn't do in heavy timber. And I think that made it difficult in a lot of cases to do an actual type 4 heavy timber building. Now, per 2021, we can do some concealed spaces. And again, I'll let you read this slide. But this is something you're obviously going to want to revisit. Or, we're here to help you with these things. So if you're going to get into any of these types of buildings, call us, email us, let us know how we can help. That's what we do, and we enjoy doing it. We have a great help desk that supports us for a lot of highly technical information. We also have 2 engineers assigned to mass timber alone. So one of our engineers handles current mass timber buildings 6 stories and less, and our other engineer handles these types of tall wood buildings that we're talking about today. So they spend a lot of time doing it, and they're really experts. So we can put sprinklers, we can put non-combustible insulation, or we can put type X gypsum on the mass timber surfaces. I think this is really, really a huge deal to make it much easier to do mass timber buildings, because concealed space is really, for lack of a better word, threw a monkey wrench into some of those buildings. And again, we can see the requirements where we can do this in heavy timber. And I'll just let you take a look at how some of this is accomplished. Pretty straightforward, really. So shaft enclosures can be mass timber. And this can work very well. This is a very, very efficient way of building these shafts using especially products like CLT. So again, we can look at the differences between these buildings. What can we do? But only up to 12 stories or 180 feet in the case of the type 4. And again, I'm going to let you read through this. We get above 12 stories, the shafts are non-combustible. And we can see the difference between the protection of 4B and 4C. Tall wood can equal high rise. So typically, when we want to determine if we're a high rise building, this is the measurement for, I guess, no pun intended, but that's 75 feet from the lowest level of fire department access to the top of the highest floor. Anything less than 75 feet is not considered high rise. So sprinklers in high rises, we're looking at 2 water mains if building height exceeds 420 feet, or we're using type 4A and 4B that exceed 120 feet. Again, we're being very conservative. I think the code did a really good job of saying we really want to take a conservative approach. CLT char fall off. Now, because there's glue lines, you can have fall off, and that has been tested and it has been calculated. So there's calculations for CLT when we're looking at char that take that into account is really the best way to summarize that. And you can have fire regrowth. Once a piece falls off and it's still exposed to the flame, that next layer is going to start to char. And that's why they did testing on this different than you would for, let's say, a 12 by 12 timber. So this is only considered in tall buildings, not applicable in mid-rise mass timber or any building under types 2, 3, 4 heavy timber or 5. And the PRG 32018 requires these higher temperature resistant adhesives. And as far as I know, every manufacturer now does adhere to that. And then under 2021, all CLT is required, but all manufacturers should be currently doing that. So there are earlier versions of PRG 320. So we want to make sure that we're using PRG 32018 and it's referenced in the code. This kind of reads through what I mentioned to you a little bit earlier. Just always remember PRG 32018, and of course, it's in the 2021 code. That's going to be required. Connections. We're going to, I guess, skip through here. Well, we'll go through this pretty quickly to allow enough time for questions. So you can see there's some pretty fancy connections. So building elements are required to be fire resistant rated. The connections also. So that's critical. So there's a lot of ongoing testing going on, and then we have to look at ways to protect the connections. Again, I'm going to go quickly through this in the interest of time. A lot of testing has been done. These are some fire test results that have been done for various manufacturers. There's probably more than this now, and we're going to see a lot more, I'm sure, based on utilizing the 2021 code. Manufacturers are going to take the time and spend the money, to do this so that they can market these connections and everybody can know that they are meeting, 1.5, 2 hour type fire resistance. The Softwood Lumber Board, who's our major funder, has done a lot of, funding for research, you would say. So there's a lot of tests that have been done. Penetrations, we're going to kind of skip over this a little bit. We know that we really need to look at penetrations and fire stopping. We're not going to go too deeply into this. This is something we can help you with if we need to get into this type of detail. And again, we work with people like Hilti and STI and other people, so we can always refer you to that. Again, the fire tested penetrations in mass timber assemblies. There's an inventory of that on our website. Sealants, sometimes panels are tested with sealants. If the panels have been tested with sealants, the sealants are required. I'm not going to spend too much time on that. There's different sections of the code that we need to look at these types of protection of mass timber for incidental use separation. Bear this in mind. Again, we're not going to spend time on this. Fire safety, there's code provisions for fire safety. It's really, really critical that we adhere to this. Standpipe requirements. So the key here is, as we're building these buildings, we're only going to go up a few floors and we're going to make sure that we're protected. So you can see if we're above 6 stories, at least one layer of non-combustible protection shall be installed in all building elements more than 4 floor levels. So as we go up, we need to install protection. We can't just build a 10-story mass timber building and come back and install the protection later. That's basically what this is getting at. And again, this pictorial will really explain it a little better, but it makes perfect sense. I think just being cautious and saying, well, we're going to protect this and we don't want all of this wood exposed. So that's basically how we're going to deal with it. Every 4 floors, we're going to come back and add protection. So with that, I think we've allowed enough time here for some questions.
Thank you, Archie. I really appreciate it. So just as we get started with questions, if everybody looks at their screen for a moment, at the bottom toolbar, you'll see a reactions button perhaps with a raise hand. So you're welcome to use that as an option, and we will try to, because we're a pretty manageable size group today, we should be able to give you a chance to actually ask your question directly rather than I do it. So I see a question with Terry. Would you like to come off mute and ask your question?
Yes, Archie, hi.
Hi.
What about, as we're looking at this image right now, what about the exterior and the maximum sort of, if you wanted to maximize the amount of wood exposed on the outside of the building? In other words, I'm impressed by a lot of mass wood buildings that look incredibly mass wood on the inside, but may not appear on the outside to have wood at all. I mean, you know, you've got a big range there, but what if you wanted this wood look on the outside as well? Could you talk a little bit more about that?
Well, to me, Terry, and by the way, how have you been? It's been a long time.
Yes.
Yeah, no, you're not going to get wood on the outside. I mean, in a tall wood building. And for, you know, we go back to, what was it, that Greenfell building in London? You know, it's an issue. But beyond that, first of all, mass timber is really not typically designed to be exposed to the elements anyway. So you're not going to be exposing mass timber under almost all conditions to the weather, just for that simple reason. So I think that's one of the things, but also, of course, fire safety. So unfortunately, the wood look is going to be achieved by a, you know, a concrete type or metal type panel. And we've had people want to expose things like CLT and think, you know, to the weather. And even if somebody, you know, kind of comes up with a way, I would caution that. And I would say, if it's my building, knowing what I know, I'm not going down that road, and I'll let somebody else be the guinea pig, so to speak. So unfortunately, Terry, yeah, we're just not going to get exposed wood on the outside of these really tall buildings.
So these panels that we're looking at here in this current image are something that is made to look like wood. Is that right? But it's some other material.
Yes. Yes.
And yet at the same time, of course, we have buildings that do have wood, that are wood to the exterior, right? They're just not mass wood buildings. And so
lower buildings, sure.
Yes.
You know, yeah. To a certain height, you can get by with the wood. You know, 4 or 5, maybe 6 stories. In fact, it was interesting because I happened to be at this site when they were still installing some of these, and all of this was prefabbed, and they were craning all of this into place. It was pretty interesting to see how quickly it went.
Mm-hmm. Thank you very much, Archie.
Sure. I wish I had a better answer than that, but I guess the truth is always the best, you know. So.
Yeah, right. No.
Hi, Ryan.
Hey, Archie, how are you?
Hi, Ryan.
I'm from Muskegon, Michigan, and I just purchased about 35 acres on the south side of Muskegon, like I'm looking at doing a long-term 10-year redevelopment plan. And Muskegon, as some people might know, has a very, very deep and rich history in the lumber industry. Muskegon rebuilt Chicago after the Great Fire. It's where all their lumber came from. And I have a huge interest in trying to make all the buildings, if possible, constructed out of mass timber. I am not an architect. I am not an engineer. So my questions are going to maybe be too basic, but fundamentally, in the 6-story building, 75,000 square feet, 15,000 square foot of floor, what surfaces can I not reveal as wood? Because I would like to have wood ceilings, wood walls, wood superstructure. I would like to have wood on the outside. I really want to hammer home this idea of using, you know, a fully wood building, because I think it's historically significant to the town. And I just couldn't quite follow along with all the technical code items that you were going through.
Yeah, there's a lot of stuff there. No, it's a great question, Ryan. I mean, you're really, based on what you're doing, you're not doing what I would call a huge building. So again, if you use type 4 heavy timber or type 4C, you can expose all the wood. So you can do that. The exterior, I'm not sure about how high we can go on. Anthony, I don't know if you even have an answer for that, as how high the exterior wood can go up, if we can get up to 6 stories.
Yeah, off the top of my head, I'm not sure either. The facade or the building envelope gets to be kind of a tricky area based off of what Archie was saying before with both just durability concerns and then also the fire protection aspect of it.
Well, I think, you can, there's a couple ways to do it. First of all, if you really had any limitations, you could potentially use a fire retardant treated wood product on the outside. So to give you an example, you can buy cedar shakes that are fire retardant treated. They use them in California. So, but cedar on the exterior is most likely, I think, it's the first thing I would look at for exterior use, because cedar is readily available and it's very decay resistant. Redwood would be great, but I don't know if anybody's going to be able to afford redwood. So you do have some products there. The rest of the building, the mass timber building, most likely the 4C would be the building that you'd probably want to use. But even the heavy timber, you'd have to, we can help you with that, decide which one would make the most sense. But you can do what you want to do, I guess, is the bottom line.
The other question that I had was, you said that the state of Michigan currently has IBC of 2015. Is that correct?
To best of I think they've been working on 2018, but currently it's 20. And I know Michigan has a couple little modifiers in there too, but basically it's IBC 2015.
So in the city of Muskegon, we have a very, very willing administration. From what I understand, the 2021 IBC accommodates using mass timber with a little bit more of an understanding as to what the technology is capable of than in 2015, 2018. In general, is a municipality able to elect to use a different IBC, or are they restricted to whatever the state has and that's all they can do?
Well, I can tell you what we see in Wisconsin. There's variances, right? That you apply for a variance. So you could say, I want to do this building and I know we're in 2015, but I'd like to use some provisions from the 2021 code. And that usually is a local jurisdiction. I can't speak for Michigan on the whole, but I would think that they might have the ability to do that. But the good thing is with what you want to do, if you do a type 4 heavy timber building, you can basically achieve, well, it's 6 stories would be a business, 5 stories if it's residential, but you can achieve what you want to do under 2015 code for the most part. The only thing you'd probably have to do is talk to them about concealed spaces and see if they would accept that from the 2021, but you're kind of 90% there.
Okay. And then the last question that I was going to ask, when you're talking about like mechanical chase and things like that, I've read on very preliminary into this. I wasn't going to be doing.
Yeah, I'm having trouble hearing you, Ryan. For some reason, I don't know if you're just breaking up on me.
Same here.
Yeah. We're having trouble hearing you. It's just kind of breaking up.
I'll follow up later. Thank you.
Sorry, yeah, it's just, early on it broke up a little bit, but then everything else came through and it's back to doing that a little bit.
All right. Thank you.
And send me an email, give me a call, give Anthony a call,
Yep.
However, we're happy to help.
Sure.
All right, I believe we have one more question that just came in. Jinpeng, would you like to turn on your mic?
Oh, yes. Hey, Archie, how are you?
Good. How have you been?
Doing good. Thank you.
Good.
I have a quick question about the fire retardant treatment of CLT. Seems like in the code, it's adding another non-combustible material is more like preferred way to deal with the fire issue. Is treating the CLT with fire retardant an option at all or not? Not
that I know of at this point in time. I'm not familiar with anybody that's, now, I think it may be possible, but what you have when you get into fire treating things like CLT and even glulam is, the fire treatment and you have a glued member. and they don't always go very well together. They cause some issues. And I know that that's been worked on. You know, for instance, we'd love to have a fire retardant glue lamp beam that we could use in exterior walls of type 3 construction. But I'm not aware of anybody who's been able to pull it off, and in particular in CLT. I don't know, you know, if you're looking at the mass timber aspect of it, I don't know truthfully how important that would be, or it might just be, it might be easier and more cost effective to say, let's put one more layer of wood on this CLT panel. Because the fire retardant treatment will definitely, you know, fire retardant treatment, even in a light frame wood building, before our lumber costing things now, would easily add 50% to the cost of the material, if not more.
Mm.
So it is an expensive proposition.
Interesting. Thank you.
All right, thank you very, very much. Archie, if you could just move one slide, I believe. I'm guessing it's just one to our closing.
Yeah, of course, now it doesn't want to cooperate with me.
If it doesn't get there, it's okay.
I click
there
on
you
the
go.
screen and it works.
Well, thank you all very, very much for attending today, and a special thanks to Archie for your presentation, Shannon for her opening remarks. If you missed it, Michigan is working to try to accelerate the adoption of mass timber related 2021 codes. So feel free to keep an eye out for more information on that as we go forward. So thank you very, very much, Archie. Thank you to Anthony for joining us as well. We look forward to working with you in the future. And as you can see on screen, there are some additional webinars coming up in May and June and more thereafter. So please don't hesitate to register at your convenience. And thank you very, very much.
Thank you, Julie.
Thank you, Julie.
Thanks,
Thank you,
everyone.
everyone. Thanks, Archie.
Take care.